This video is going to look at what's called domain and range. Before we look at domain and range, the first thing we're going to talk about is number systems. Basically, there are different types of number systems, and number systems are sets of numbers. The first set that we'll look at is what's called a whole number. So whole numbers are represented with the symbol W, which is in brackets here. And whole numbers are just counting numbers. So if I count 1, 2, 3, 4, 5, and so on, those are called whole numbers. To expand this set, we're going to look at what are called natural numbers. So natural numbers are represented with the symbol N, and they also include one other number, which is 0. So 0, 1, 2, 3, 4, and so on are called natural numbers. The next set is what are called integers. Integers are whole numbers and natural numbers, but they also include negative numbers. So -3, -2, -1, and then further negative numbers, as well as 0, 1, 2, 3, and then larger positive numbers, all fall into the set of what are called integers. As I make my sets bigger, the next type of number is what's called a rational number. Rational numbers are any type of numbers that can be written as fractions. So they include those positive integers, -3, -2, -1, and so on, as well as the fractions that are in between. So -1/2 or +1/2 or +1/4, anything that can be written as a fraction. So whole numbers can be written as fractions, whether they're positive or negative, as well as whole numbers with numerators and denominators. They're all called rational numbers. The next set also looks at numbers that can't be written as rational numbers. So I can either have a number that's written as a fraction, or a number that's called irrational, which we're going to put a bar over the Q and call it Q bar. Those are irrational numbers. And those are numbers that are decimal numbers that are non-repeating or non-terminating. For example, pi, √2, √3. These are all numbers that are non-repeating, non-terminating decimals, which means that the number after the decimal will continue and it will never repeat or never end. The last set of numbers is an accumulation of all these different number sets. Whole numbers, natural numbers, integers, rationals, irrational numbers, all of these numbers are grouped into one set, which we call the real number set. So real numbers is represented with a capital R. So real numbers are all of the numbers that we've just talked about in the sets above. So now we can talk about a domain. The domain for a relation is the set of all the possible x values that can be put into that relation. So when we talked about relations, we said that relations are sets of ordered pairs. The x values are also referred to as the input, and all of the possible x values that can be put into that relation are called the domain. Similarly, we said that ordered pairs have x values as well as y values. So the range is the set of all the possible y values in a relation. We also call those the output. Let's look at an example. If I have this set of ordered pairs, 3 and 1, 6 and -2, 0, 5, 10, 5, 7 and 1, we want to state the domain and range. So the first thing we're going to look at is the domain. And we said the domain is a set, so we're going to use the same set brackets that we used to indicate that something is inside of a set. And what we're going to do is we're going to list all of the possible x values that occur in set A. So when we're listing our numbers in the domain, we're going to start with the lowest number. If I look at each of the x values in my set A, the smallest x value is 0. Listing them in order from smallest to largest, the next one would then be 3, then 6, then 7, then 10. So these 5 digits make up the domain of set A. Similarly, if I want to look at the range, we're going to look at now the y values that occur in set A. Again, listing them in our set brackets, I'm going to look for the smallest number, which is -2. The next number that occurs would be +1, but as you'll see, it occurs twice. I only need to list it once in the range. The next number that occurs in the range of A is 5, and that's the last number Even though it repeats, I'm going to list it once, and I'm going to close my set bracket. So the next example we're going to look at is looking at the graph of a relation. This is a parabola similar to what you've seen in grade 10, and we're going to state the domain and the range. There's two ways for us to list domain and range when we talk about a set of numbers. One is called set notation. So if we look at this parabola, we'll notice that all of the numbers along the curve are listed in the domain. So what I want to do is I want to look at every single x value that occurs along that entire curve. So I can see that 1, 2, 3, 4, 5 are all positive x values that are numbers that can be put into x for my parabola. What I also notice is that the numbers in between are also part of that set. I can put in the number 1/2 or 1/4, and I can continue to make that x value smaller to list all the infinite values between 0 and 1, or between 1 and 2, and between 2 and 3. So how we want to write this as the domain is we're going to put them as a set. So again, I'm going to use the same set brackets we used before. So I'm going to open the set, and I'm going to write that x, because we're talking about the x values of my function, is all of the possible values between negative infinity and infinity. So we said that all the different types of numbers in that set of whole numbers, integers, natural numbers, rational and irrational numbers, those are called the real number system. So we're going to use a symbol that looks similar to an E, but it's curved, and this is called an element. So this symbol means that x is an element of, and we're going to use the real number system, so we'll put that capital R and close our set. So this statement says that the domain of the parabola is x that's an element of all real numbers, meaning all real numbers are possible values that can be put into the relation. Okay, let's look at the range. The range is a little bit different. Here we'll see that the parabola opens up, so all of the values in the range for y will continue infinitely up. However, there is a lower minimum value. The minimum value for this particular parabola is -4. So again, I'm going to use a set to indicate my range, but this time y will be all real numbers that are above and also equal to -4. So after writing x as y as an element of real numbers, we're also going to put a line that means such that y is going to be everything that's greater than or equal to -4, and then we'll close our set bracket. Another way to write this exact same domain and range is what's called interval notation. So interval notation is going to use brackets, and it's just another way to write a set. So let's go back to the domain. We said that the domain of this function was all of our possible x values, so any x value inside the real number set. When we're writing interval notation, we're going to start off with a bracket, and we're going to look at the lowest number that could possibly be put into the domain of this function. If I look at this relation, the smallest x value would be -infinity. Since -infinity is not a tangible number, we'll use a round bracket to say that it doesn't include an actual digit, and we'll write -infinity. That's the smallest number and the start of our set. I'm going to put positive infinity as the largest number that can be in this domain, and I'm going to close it with a round bracket. So again, we said that round brackets mean it doesn't include the number infinity, because we can't actually come up with an actual number for infinity. So we'll use round brackets. The range, like we said, is a little bit different. It has a minimum value of -4, but it includes that value of -4. So instead of using a round bracket, we're going to use a square bracket. And what the square bracket means is I'm going to use everything including the number, which is going to be -4. That's my smallest value, so I'll put -4 on the left side of the bracket, and then it goes to positive infinity, which I'll close with a round bracket.